So we are playing with ratio and proportion. And we already started playing around with ratio because that's one of the ways we could look at what a fraction is. So sometimes we write a ratio as a fraction, 3/4. With a ratio, though, we might write it as 3/4 instead of saying 3/4. Sometimes you might see it as 3 colon. Come on, little circle there. 3:4. And as far as the fraction version, sometimes we use the slash instead of the fraction bar. But they all mean the same thing. And sometimes we just really mean it as a fraction, but sometimes we're comparing two different things. For example, it could be something like a group, and in the group there are 3 men to 4 women. Or in the math for elementary school teacher class, it's usually something like 1 man to every 10 or more women. So typically when we're looking at a fraction as a ratio, we're comparing two different things. Okay. Other things we look at to do those kinds of comparisons are rates, which are a kind of ratio. And a rate would be something like miles per hour. And the per literally means divide. So it could be something like I went per hour. I went for a 10-mile bike ride with a friend of mine the other day, and it took 1 hour. So that's literally 10 miles divided by 1 hour. So we'll play around in this section comparing rates and ratios that aren't exactly rates in terms of comparison. It'll also come up with things like similar figures. So figures are similar if they have the same shape. And if they have the same shape, then there's going to be common ratios. For example, we could be talking about a rectangle. And if I make a rectangle that is, say, 1, 2, 3 units tall, and then 1, 2, 3, 4 units wide, a similar rectangle has to have the same shape. What rectangles could have the same shape? Well, I could double the sides. So instead, I could have one that's 6 by 8. Then they have the same shape. Not all rectangles are similar in shape, though. Like suppose I made a rectangle that was 3 by 8. Is that the same shape as the rectangle I started with or the new one I made? The answer is no, that's thinner, wider, right? It's not the same shape. These two rectangles are similar, they have the same shape, and the way we justify that mathematically is if we look at something like the ratio of the height to the width. So if we take the height and divide by the width, for the first one, the height was 3 and the width was 4. The second one, my height was 6 and my width was 8. And two figures are similar if those two ratios are equal. When we set two ratios equal like that, that's called a proportion. So ratio, we just compare two things with division. Proportion is when we set two of those ratios equal to each other. And as far as shapes go, if they're equal, that means those figures have what we call the same shape. Same shape means common ratios. And it's like blowing something up or shrinking it, right? Magnification of an object. Sometimes, though, we don't know all the information about it. So let's say we're going with these rectangles here. Similar rectangles. And let's say I have a digital image that has a height to width ratio, like we were just playing with, of 3 to 4. Right? If you go to Walmart and you get some pictures off your phone printed, that's a common size, 3 inches by 4 inches. Then someone says, well, I want it printed bigger so it fits I can fit it in a nice big frame to hang up. And they say, I need it to be 12 inches wide for sure. But it's got to have the same shape as the original picture, right? Otherwise, we have to cut some of it out if it's not going to happen. So a lot of times we solve these proportion problems to find a missing part of it. So what height would I need in order to have the same shape rectangle? Yeah, so we can play. Now here you can kind of just guess at it in a couple of ways. Like you might say, oh, 4 times 3 would give me 12. So we better do a times 3 there. Would be one way to think about it. You may remember from a previous math class where you did a cross multiply and divide to solve something like that. So a common way to solve this might be to multiply like that. 3 times 12 is 36 equals what times 4? And then we divide out the 4. And we get the missing side has to be 36 goes into 4, 9 times. Do you always have to cross multiply and divide? The answer is no. If you happen to set up your proportion so that the missing number is in the top, then really all you need to do is multiply that bottom number underneath over the other side. And that's a quicker way to get it. So this would be whatever 3 times 12, 3 times 12 over 4 is. And then maybe whip out a calculator, we figure out, oh yeah, it's got to be 9. And sometimes they work out nice and sometimes they don't. For example, let's do a similar one. What if, again, we have some photo, the photo has a 3 to 4 height to width ratio. And we want to figure out what should the height be, question mark, so that the width is 10. Do me a favor, make a calculation. What's it going to be? Write something down. Oh, yeah. Calculator if necessary. If I use that trick I had before, I would just multiply the 10 over. So my missing height has to be whatever 30 over 4 is. How many times does 4 go into 30? 7 and a little bit. So, oh, 7.5. Yeah, that's not bad. With 2 left over, so 7.5 on the calculator. We're in the fraction section, so maybe I'll call it 7.5. So there's a few different ways to think about it. So that's not too bad. Other times it's going to be messier. Not all decimals like this come out nice when we do division. So the idea here is we're using this geometry idea of same shape. Another cool way to think about this, well, I think it's cool, you may not, is remember back in algebra, you graph things like y equals mx plus b a long time ago. And if we say, forget about b, and we just consider y equals mx, that just means the y-intercept is 0, and it passes through the origin where the y and x-axis meet. So if we think about my idea earlier, and where I was saying the height divided by the width was always 3/4, I can multiply the width to the other side and get the height equals 3/4 times the width. And this way of looking at a proportion is like looking at a line. It's the same idea. So if I were to graph that, then I'm always going to find heights compared to widths where it's up 3/4. So that point right there is going to be on my graph. And that would be the line y equals 3/4 x. But here, the y is my height, and the x is my width of some similar shaped rectangle. And then geometrically, this right here would be my original 3/4 image that I started with. And then anything else we calculated, like we calculated back here, that if the width was 10, the height has to be 7.5. So if that's 4, 5, 6, 7, 8, 9, 10 is over there. 3, 4, 5, 6, 7, 8 would be up here. 7's right there. But in that rectangle we found that's 10 by 7.5 has to have a corner on this line and the other corner down here because they're the same shape. What was the other one we found? 12, 9. So if we wanted to have the same shape rectangle and we say the width would have to be 12, then we found that the height had to be 9. So that would be up here. And all those rectangles have the same shape. Anybody know another word for rectangles that have the same shape? When we look at the height and the width. Anybody ever do any art or design classes? No? Anyone online? You guys are so quiet today. Can you help me out with this? Anybody own a television set? Yeah? No? The shape of the screen is called the aspect ratio. Oops. Does that sound familiar? No? You've never heard that phrase before? Come on, really?
You lost me there.
So aspect ratio is just the ratio of the height to the width. And as far as TV screens that you buy, so if you go to, Walmart or Buy-Mart or any store to buy a new screen, it's most likely going to have an aspect ratio of 16 to 9, because that's the most common format that TV shows and movies are shaped in, the rectangle that we see on the screen. And if your screen isn't that dimension, 16 to 9, that shape, then when it's displayed on your screen, something's getting cut off. Either the top part of the top or bottom are getting cut off, or parts of the left and right are getting cut off, so it fits on your screen. Think about laptops. Are all laptop screens the same shape? Turns out they're not. There's a lot of variation in laptops screens, more so than there are in TV screens. Most TV screens, high definition TV screens, pretty much fit the 16 to 9 ratio. So if somebody says, oh, I got a 52-inch TV, then what they're saying is, so TV aspect ratio. So that's 9, 16 is maybe that big, my best guess. So here is a 16 to 9 ratio. And if they claim that their TV's 52-inch, that means TVs usually measure the diagonal when they talk about how big the TV is. So a 48-inch versus a 52-inch versus a 64-inch, that's the distance from one corner to the opposite corner. And regardless of the diagonal length, most TVs, the length, if you take the width compared to the height, you're gonna get 16:9 if you divide those. So you might do this when you get home. Go home, whip out a ruler or tape measure, measure the length of your TV, measure the height of the TV and divide them, and it should come out to whatever 16 divided by 9 is. You're laughing at me. You're not gonna do this? Okay, how about if I give extra credit for it? Oh, fine, then I'll put it on the test. How about that? Yeah, go home, measure your TV screen, take a picture and show them the measurements. That'd be the test question, wouldn't it?
Okay, so it's not extra credit now?
It'd be both, maybe.
We
Alright.
have 3 different teams.
Measure all of them. Yeah.
That's your receipt.
5 points each. How about that? I'm serious. Send it out. This is like active math. Let's do it.
I have a question that I don't know if you already know where